Question 4 is a nice little modulus equation to go for. You start by having to draw the picture, and well, you would have done that anyway, wouldn't you? So when does this equal 0? This equals 0 at 5 over 2 here, and we've got the V shape like this. It's crossing here at 5. I can see that from just flipping that up there, and 5 over 2. I've tried to draw it as symmetrical as possible about that point, and there we are. Part B says, when does this greater than 7? Let's put 7 on. So 7 is going to be about here. So I'm expecting two answers to look for here. And let's do these algebraically. So when 2x minus 5 equals 7, add the 5 and divide by 2 gives me that it's going to meet when x is equal to 6. That must be that point up there. That's when x is equal to 6. And if 2x minus 5, when the modulus does it work, is equal to minus 7, and so if I add the 5 to that, that gives me x is minus 1. This point here must be when x is minus 1. We want this thing to be bigger than 7, so we want this bit down here. So we want when x is less than minus 1, and this bit up here when x is greater than 6. I think I'll stick a little union symbol between them to show off that I can do my set notation as well. So that's that part there. Now find the values which satisfy this formula. Let's just go with this algebraically to begin with. So if there was no work being done with the modulus, if I take away the x and add the 5, it actually gives me just x equals 5 over 2. But if the modulus did its work, and this became negative, minus x plus 5 over 2, that would give me 3x equals, what's that? That's 7.5. That gives me x equals 5 over 2 again. So this has found out that this line here, x minus 5 over 2, x minus 5 over 2 is actually a straight line here that just touches in this one point. That tells me that the blue one is always above the big one, except that one point. The only time the blue one isn't above the red one is when x is equal to 5 over 2. That's the only point there. It only crosses once.